Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today's topic is one we've covered before, although not recently, but I have realized over the past several months that there's still some confusion on the topic. So here's our topic for today. What is MQTT Sparkplug? So we've talked about MQTT as a communications protocol. We've also mentioned Sparkplug as a key part of that presentation. But today I thought it was really important that we really zero in on MQTT Sparkplug. What is it? How is it different from MQTT in general? And why, as an industrial user, is it important to you? All right, so that's our topic for today. Let's take a look at how we break it down. We're going to start out with just a few minutes talking about the whole Industry 4.0 and the industrial Internet of Things, and why are we looking to connect more machinery to get more data. We're going to talk about what is MQTT in general and how does it work, and spend plenty of time on what is MQTT Sparkplug in particular, how is it different from generic MQTT, and what are some of the problems that it solves in industrial applications. Okay, Industry 4.0. What is Industry 4.0? Well, that's the discussion about the different industrial revolutions that have occurred in our society. Version 1.0 is mechanization using water and steam. We moved to the mass production and the assembly line using electricity. We adopted computers and automation. And in the latest version, 4.0, it's all about smart autonomous systems fueled by machine learning and increased machine data. The whole idea is that smart machines keep getting smarter as they access more data, helping factories become more efficient and more productive and less wasteful. Now, in order for Industry 4.0 to occur, it means we need to get more data out of more machines. And that means a network or additional data access, or the industrial Internet of Things, sometimes abbreviated as IIOT. The industrial Internet of Things, again, is all about getting more data out of more machines. And, I'm a graybeard, and I know that machines have been sharing information for years. So this isn't really all that new, at least in terms of getting data out of machines. We've used supervisory control and data acquisition packages, sometimes called SCADA. We've used historians. All those have been in use for some number of years. But the factors that make Industry 4.0 a little bit different than our traditional industrial data use is just the scale of connectivity, the sheer volume of machines that we want to connect, the sheer volume of data that we want to gather. Okay, and that data could end up in a server somewhere in our facility. It could end up in the cloud, but there's going to be a lot more data than we've dealt with in the past. So all these factors contribute to the need for new approaches to data acquisition with machines and new protocols. So that's where MQTT comes into play. MQTT is a protocol. It stands for Messaging, Queuing, Telemetry, Transport. It's one of the new approaches to connectivity for gathering all this data from machines that are demanded by this Industry 4.0 movement. Now, MQTT is based on a publisher-subscriber model. Traditionally, in our industrial communication networks, we've used a poll-response approach, where we have a client application that is polling a series of server applications. Those servers might be PLCs, they might be drives, whatever the case may be. And these clients are continuously asking for data from the servers in this poll response approach. With MQTT and its publisher-subscriber model, it's more of a report by exception scenario or a push scenario, where the PLC device itself is sending the data upwards as opposed to sitting around waiting to be polled. And MQTT has been designed using this push approach so that it works really well with both reliable network architecture, where you've got a solid LAN, maybe 100 megabit or gigabit at your disposal, or maybe where you don't have a solid LAN, where your only connection with the machine is over cellular, over a radio modem, or some other low bandwidth approach. Now, a few other facts about MQTT. It did start out as a proprietary protocol back in the late 90s. All right. It was first used in oil fields. And think about the oil field environment. You have a lot of sites or facilities or equipment spread out over a wide geography. Often the connectivity available to that equipment is maybe over radio or over satellite, even in some cases. So you don't have a lot of bandwidth at your disposal, yet you have a lot of equipment you want to communicate with. So a need for a protocol like MQTT made a lot of sense. And so from those early beginnings, in the last 10 or 12 years or so, that's where the standardization of MQTT has occurred. Now, how does MQTT work? We talked about the fact that it's a publisher-subscriber model. So let's take a look at that. Okay, so what you start with is a device that has data to share. Now, instead of some device going and pulling that data out, it's going to publish that data itself, okay? And it's going to publish it at a rate which is appropriate. So maybe once a second, maybe once an hour, maybe once a day, somewhere in between, okay? Or maybe only when it changes. And it's going to publish that data as a topic to a separate device called a broker, and sometimes called a server. It's the same thing. And the whole job of the broker or server is to act as the data handler. So it gathers all the data from all the publishers, okay? And other devices that are interested in that data can be subscribers, where they can get in touch with the broker and say, hey, I'm interested in that data. Can you share that with me? And then as data is updated by the publisher, the updated data is passed on by the broker to the subscribers, okay? And the whole idea is that when connections are lost or broken, maybe the publisher stops publishing data, the broker's job is to notify all the subscribers that that's occurred. Now, MQTT these days is almost always built on TCP/IP, okay, Ethernet backbone usually, and TCP/IP includes error correction, so that's also useful. MQTT does support encryption using TLS. It isn't always used, it's optional, but it's available. Again, as I mentioned before, a broker is sometimes called a server, and sometimes the publishers or the subscribers are called clients. And then sometimes you can have a publisher that also subscribes. So you could be a client that's both a publisher and a subscriber simultaneously. Okay, now what are some of the advantages of MQTT? Well, it scales up really well, okay? Let's say I've got a traditional pull response type architecture in my plant, and I've got a SCADA package that is polling, let's say, 20 PLCs to get data. And maybe it takes, let's say, 10 seconds, or say 10 seconds to get that data. Well, suddenly, my management is demanding I connect, let's say, to 200 or 1,000 PLCs. Scaling up that connection or getting all that data using pull response is going to be a problem. But if each of my controllers or devices can push data instead only when it needs to, only when the date is changed, only when it's important to be communicated, suddenly that limited amount of bandwidth that I had available or that I have available can be put to much better use. Okay, so that's one of the key advantages of MQTT. And again, even if I don't have a really robust high bandwidth network, MQTT can work as well. So if I've got a radio modem or if I've got some sort of cellular connection, it can work as well. Another advantage of MQTT is it's fairly lightweight. In other words, it doesn't take a really sophisticated device in order to run it or in order to use it. Now, it does usually involve Ethernet, so you've got an Ethernet stack somewhere in the code. So it's not like it's completely lightweight, but it can absolutely be used in applications where the devices that are connected over MQTT aren't necessarily the most sophisticated. So the result, of course, is between all these advantages, now we can connect more machines of more different types to the same amount of bandwidth. But there is no free lunch, of course. What are the disadvantages of MQTT? What's the catch? Because there's got to be some, and surely enough there are. First of all, MQTT was not created strictly for industrial applications. The specification as was originally created was kept intentionally fairly vague and fairly bare bones, with the idea being that this communications architecture could be used in a whole variety of different applications. So they didn't want to put a lot of overhead or a lot of requirements on the protocol that some applications wouldn't handle very well. However, whenever you have a specification that doesn't have all the details filled in, you can have issues. Okay, so some of the details that weren't filled in included: how is the message data that's being sent, how is that formatted? How is the data organized? There were some loose specifications on how it should be organized, but again, very loose specifications. And there were some facilities for being able to tell that a publisher of data, for instance, was offline instead of online, but there's probably not enough meat on the bone there to really do a fully effective job as the original specification was written. And again, anytime you have details that aren't filled in, one of the real problems is interoperability, because different manufacturers attempting to support the same protocol with limited amount of details will make the rest of the decisions themselves, fill in the rest of the details the way they want to fill them in, and you end up with interoperability issues between manufacturers. So that's where MQTT Sparkplug comes in. So what Sparkplug did when its specification was created is it added the definition necessary to allow MQTT to be used in real-time industrial applications. So it didn't replace the MQTT specification, it supplemented it. And it was really designed not only to make MQTT work well in a real-time industrial environment, but also to take care of some of the interoperability issues that came up because there just weren't enough details filled in. So the gaps that were filled in were the ones that you need for the industrial applications. First of all, state management. You need to know if the source of data is actively up and running and that you're monitoring the latest version of that data. In an industrial application, if you don't have the latest version of the data, the results can be very bad, obviously. Okay, so state management was beefed up with Sparkplug. Also, the topic namespace, the way that data or topics are organized, was given a lot more structure. And the way the data was formatted over the wire, the payload as it's called, the way that payload was formatted and actually sent as bytes across the wire, that was also beefed up significantly to really help in those industrial applications and with the interoperability issues. Okay, so let's take a look at what the architecture looks like specifically for Sparkplug. Now, a lot of these components are similar for just generic MQTT, but there are definitely some differences. All right, so let's start with the heart of the system, and that is the MQTT broker, again, sometimes called an MQTT server. That's the big circle in the middle of the diagram. That handles all the messaging. So every device that's publishing data publishes it to the broker. Every device that subscribes to data is subscribing to the data and getting it from the broker. So the devices on the right are doing the publishing, the edge nodes, if you will. And then you'll notice a device at the top that's called a host. And this is a little bit unique in Sparkplug. This is a special type of device that's defined in Sparkplug, and that is a host Sparkplug device. And it's really designed to act in the SCADA role, the supervisory control and data acquisition role that you see in a traditional industrial application. That's the role that the Sparkplug host is designed to fit. And we'll talk about that in more detail in a minute. And then on the left, you have your traditional, let's say, subscribers to data that, historians and manufacturing execution systems and those sorts of things, analytics packages, that sort of thing, that are taking a look at the data, but as a subscriber, not necessarily as a publisher. So that's the architecture we're talking about. Now, as we dive in a little more deeply into those different types of devices in the MQTT or the different components in an MQTT system, let's talk a little bit more about the MQTT host, because it plays a role. As I mentioned, it acts in the SCADA role that traditional industrial applications have. And as part of that role, it basically is responsible for monitoring and controlling the edge of network nodes. Okay, so just like with a SCADA package, where you're monitoring live data from the plant floor, you're changing set points, you're making adjustments, that's the same role that the MQTT host plays in a Sparkplug application. The edge of network node is the PLC or other controlling device that is publishing data, traditionally for the most part, to the system. And again, on the left, your application nodes are primarily subscribing to the data for the purposes of historian or analytic type purposes. Okay, so we've talked about the different components within Sparkplug, and the big one that's different is that host device. But now let's talk about some of the changes that were made to Sparkplug, the supplements to the specification that allow it to work well in industrial applications. And we're going to start with state awareness. So what is state awareness? That is where, as a subscriber of data, monitoring data for whatever purpose, you need to have awareness as to whether that is the latest data and that the device that's publishing that data is online effectively. And so you're confident you're looking at the very latest data. Now, the way Sparkplug makes that work in a more robust fashion than what's built into MQTT is it strictly enforces a feature that's built into MQTT called the last will and testament. So how does that work? Well, effectively, what happens is this. So if I'm a publisher, and let's say I'm publishing temperature data in a system, then I'm, let's say, publishing a value of 69 degrees, and I'm publishing that data to the broker. Now, that data may not be changing very frequently, all right? It may only be changing, I don't know, every few minutes. So to manage bandwidth properly, but to still have confidence that the data is the latest and that the node is still online, when I log into the broker or the server, we agree that I'm going to provide a certain frequency of communications through keep alive messages. So even if my data isn't changing, I'm going to send a simple 2-byte message periodically that says, yep, I'm still here, I'm still alive, everything is good. And then as subscribers are looking at my data through the broker, of course, they can also be confident that the data they're looking at that they have is the latest copy of the data and it's up to date. Now, what happens if, for whatever reason, the publisher stops publishing data? All right, well, the keep alive signals will stop coming in, a timeout is going to expire, and then something called a death certificate will be distributed by the broker to all of the subscribers saying, hey, this publisher is offline now, so you still have the latest copy of the data that I have, but this is now an offline node, and so now those subscribers can react appropriately. And at some point, hopefully, the publisher comes back online, and at that point, a birth certificate type communication is made, and the broker updates the subscribers with not only the latest data, but also a birth certificate saying it's back online, and everybody's confident they've got the latest data again. So that state awareness, that beefed up state awareness, is a key element of Sparkplug, to be sure. Now let's talk about the more organized namespace that you get in Sparkplug. All right, so there in full color, you can see on the screen, is kind of the layout for the namespace as defined by Sparkplug, and each element is in a different color. So it starts off with a namespace, which is just a namespace field, which is just a string, which is a fixed string in Sparkplug, SPB v1.0 for Sparkplug B, which is the latest specification that's in most wide use these days. And so that basically just enunciates that, hey, this is a Sparkplug node that's reporting data here. That's followed with a group ID. The group ID is a field that is defined as a logical grouping of nodes. So if I'm in a plant facility, maybe the group ID is the name of my plant. If I'm in a water treatment type environment, maybe that group ID is a section of the county where I have a group of lift stations or something. Okay, so the group ID just needs to be a logical name that refers to a group of nodes that are reporting data. Now that should be relatively short, however, because it will be reported with every data message that gets reported by the node. All right, next we have the Sparkplug message identifier, and there's multiple Sparkplug messages. We'll talk about those in a minute. And in general, the Sparkplug message side of things is usually handled by your edge of node device that is handling the protocol. All right, then there's something called a node ID or an edge node ID. So that is the string that defines the specific node that's talking on via MQTT to the broker. So again, if I'm in my plant environment, it might be maybe I have an epoxymatic machine and I only have one epoxymatic machine in my plant. So the node ID might be epoxymatic. Okay, that sort of thing. And then there's another optional field called device ID. So if you've got, let's say, a PLC or a gateway type device that's talking on MQTT, and there's some less sophisticated devices that it's connected to, say over Modbus or something, then you could choose to, for each of those unsophisticated Modbus devices, you could choose to lump all their data together for each device and assign that as a device ID. So when it was reported as MQTT, the hierarchy would be first the edge node ID, and then under that would be the device ID. But that's a purely optional field. So certainly a much more named or defined namespace. And then in the middle part of that namespace there are the Sparkplug message type. And there I've got on the screen just a sampling of the Sparkplug messages. That's where you see that birth certificate we talked about, the death certificate we talked about, data that's just being reported as routine data, could be that temperature data that I showed in my simple little example there. And that's just what you're looking at there when it comes to Sparkplug messages. Now, when it comes to actually naming the data, the routine data that's reported, whether it's a temperature or it's a pressure or whatever the case may be, that's where we get over to the right side of the rest of our namespace that we've already talked about, and we get into what's called a topic and into what we call metrics. So the topics are a group of variables. You can think of them that way. So if you've got my epoxymatic and maybe it has a dozen temperatures and I want to lump or group all my temperature data together, I could create a topic called temperature, for instance. Okay, so it's just a grouping of variables or a grouping of metrics. Okay, and then a metric is literally a variable. So it could be oven temperature, air temperature, whatever the case may be. Now, one of the big advantages of the Sparkplug specification, the way it's defined, is it really is conducive for host devices. Okay, remember, a host device is playing the role of a traditional SCADA package, but it's very conducive for host devices to be able to browse metrics or browse tags. So in a Sparkplug system, it's extremely unusual for you to have to manually type any kind of tag name or metric name into any host software package, because with Sparkplug, all that data is available to be browsed typically. So that's a huge advantage. Okay, now finally, we've talked about state management or state awareness. We've talked about the topic namespace with Sparkplug. The third area where Sparkplug has really beefed up the specification is in data formatting. And there's really no specification at all in MQTT as to how data should be formatted. So it could just be sent out in plain text, for instance, just in straight ASCII if that's what you wanted to do. True, false, on, off, etc. The problem with that, because there's not much definition, there's also no definition not only for the format the data goes in, but what data format is it in? Is it integer, double integer, floating point? Is it ASCII text? What is it? So with Sparkplug, all that is defined, again, to help with interoperability. That's a really huge deal. Now, in terms of the way that the data is formatted, it's formatted in something called JSON, and it's encoded using something called Google Protocol Buffer, sometimes shortened to protobuf. Okay, and so that is the form in which the payload or the data that's transmitted is sent, using JSON and encoded using protobuf. Now, what this means is this. You could, as part of a test system or even, as an attempt in an installed system, you could use a generic MQTT application on your computer, for instance, that's acting as a subscriber to data with an MQTT system. And when you use this generic MQTT app, maybe for test purposes, what have you, if it's not Sparkplug aware, in other words, it's not aware of the JSON formatting and it's not aware of the protobuf encoding, then you can see the payload of the MQTT Sparkplug message that you subscribe to, but it looks like gobbledygook. It looks like it's, maybe it's been corrupted or something. But it hasn't. It's just encoded and formatted. So again, if you're going to use any kind of generic MQTT tools as part of your testing on an MQTT system, you're going to have to be aware of that issue. Those tools really should be Sparkplug aware. And there is a very popular tool called MQTT FX that we've used on this channel and that I would recommend. It's no longer free. I think you do have to pay for it, but it is a good test MQTT software client, if you will, or subscriber, and it is definitely Sparkplug aware. So now I'm going to talk a little bit specifically about the Horner OCS all-in-one controllers that we provide here at Horner Automation and how we've implemented MQTT Sparkplug. Because that literally is what we have implemented, is the Sparkplug version of MQTT. Why did we choose Sparkplug? Well, we chose it because it is by far the most common industrial application of MQTT. All right. Now, the role that a Horner OCS can play in a Sparkplug system is as a edge of network node. Okay, so it's the device that is going to be publishing the data, from the machine, whether that's temperature data, pressure data, etc. And that data could reside from directly within its own memory, or that data could be extracted maybe from lower technology Modbus devices that it's also connected to. So it can report not only its own node data, but it can also report device data if that's what you want to do as well. So again, the Horner OCS all-in-one controller acts as a MQTT Sparkplug edge of network node, primarily for the purposes of publishing data. The data it publishes can be its own node data or device data. And then this is an important point to be aware of, and that's this. Another role that the host plays in a Sparkplug system, remember, that's the SCADA type device, if you will, is that that host manages the subscribed data, or the published data, I should say, to the point where any data that the OCS publishes, if there's a Sparkplug host in the system, that data also is automatically subscribed. In other words, the data the OCS is providing to the network as write-only data, if you will, becomes read-write. So let's say you've got a set point for the level of a well that you're controlling with an OCS, and you want that system to be reporting on MQTT. Well, the OCS is going to be reporting things like what is the well level, et cetera, but it's also going to be another piece of data that it's going to be sharing is what's my current set point for the well, maybe 10 feet, 9 feet, whatever the case may be. Well, if there's a Sparkplug host in the system, that Sparkplug host can automatically see all the data that the OCS has been published by effectively browsing the tags over MQTT. And it also now can write back down to the OCS any data that the OCS allows to be written, including something like the set point for a well, for instance. So one of the key roles that the host does play in a Sparkplug system is turning published-only data into published subscribed data. Now we're going to spend just a few minutes. We've got more extensive videos on this, so I just want to cover it just loosely, and that is the general workflow, if you will, for configuring a Horner OCS all-in-one controller as a MQTT node. Okay, so you start out in the main Cscape application window. You're going to go to the program menu. Under messaging, you're going to find MQTT listed. The first level of configuration is you need to configure some controller details. Every controller that's acting as a node device on MQTT needs to have what's called a unique client ID. And at Horner, we recommend you use your MAC address, your Ethernet MAC address, as your client ID. The reason we recommend that is because a Ethernet MAC address is always guaranteed to be unique. So you're not going to have a scenario where you accidentally have a duplicate node because you've given them duplicate client IDs. So in addition to the unique client ID, there's also a group ID. Remember, that's a meaningful string for a group of nodes, or the group of nodes that individual OCS is included in. And then you're also going to give a node ID, which is just a descriptive string for that OCS sitting there as a node. Finally, you need to configure the details for logging into the MQTT broker or MQTT server. Which IP address or URL is that server located at, what credentials, username, password, etc. do I need to use to log in, and what kind of encryption details do I need to provide so that if we're using encryption in the application, it'll work properly. And then finally, it's a matter of configuring your topics, your MQTT Sparkplug topics, and your metrics. Remember, topics are kind of groups of variables that are logical to define, like a group of temperatures or pressures, or maybe all the variables for a certain part of the machine, whatever the case may be. And then metrics are individual variables, temperatures, pressures, part counts, whatever it might be, that is going to be included in the topic. And you can have, of course, multiple topics, which is typical in most applications. And then you're going to set the update conditions. When is the OCS acting as the MQTT Sparkplug node? When is it going to be publishing that data? Is it going to publish it on a change of state basis? Is it going to publish it every 5 seconds, every 5 minutes, whatever the case may be in that scenario? So let's go ahead and wrap up the topic for today. MQTT is a great protocol for pushing data from machines. It's a departure from the traditional poll and respond protocols that we're all used to. It very efficiently uses network bandwidth, which allows more and more machines to provide more and more data in this age of Industry 4.0 and the industrial Internet of Things. Now, generic MQTT has some disadvantages in industrial applications, and so MQTT Sparkplug is a specification that was created to solve some of those limitations, all right? And those include things like making sure that all the devices talking on MQTT Sparkplug are fully state aware, that the topics are defined very robustly, and that the format in which data is exchanged or reported is also defined very robustly as well. And again, it's very important to realize that generic MQTT and MQTT with the Sparkplug implementation are not exactly the same. One of the differences I highlighted was the fact that MQTT Sparkplugs are going to be publishing using JSON data that's been encrypted. And if you try and look at that data from a generic MQTT client, you're going to see what looks like corrupted data when in fact it's just encoded. So hopefully you got some good there. Hopefully we're able to solve some of the confusion around this topic, and let's hope we accomplish that for today. All right, next I want to mention that we're here every Tuesday at 2 o'clock. We love to have you watch live, or if you'd prefer, you can always watch on replay. We like to have comments and questions. If you're watching live, give those to us in the chat section. If you're watching on replay, like a lot of you do, give us those in the comment section. We try and get back to those just as soon as we can. One thing I want to mention is that we've recently merged the videos that we have with our Horner Lighting Group into our Horner APG YouTube channel. So a bulk of our videos are from the Horner Automation Group, but we now have plenty of videos from our lighting group. Remember, our lighting group specializes in industrial lighting applications for things like inspection of automobiles or paint jobs or whatever the case may be, for outdoor lighting, for indoor lighting, hazardous location lighting. We've got a great selection of lighting products, and I would encourage you to take a look at those here on our Horner APG YouTube channel. Okay, let's talk about next week. Next week, our topic is going to be all about maybe taking a routine, a logic routine that you may have written years ago that still has a lot of good functionality in it, and taking that register-based logic routine that you wrote in Cscape, transforming that into a user-defined function block using variable-based advanced ladder. So I'm going to go through the workflow for that, take an actual routine that I wrote years ago, and do exactly what I've just described. Reuse that code in the future and be able to reuse it very easily in every new project where I need that routine through a user-defined function block. Last thing before we sign out, if you haven't done so already, please subscribe to our channel. It doesn't cost anything. And if you choose notifications when you subscribe, then you'll be notified every time we go live or every time we post a new video. And we're going to hit 100 new videos in 2022. Around 50 of them or so will be from our Tuesday live streams. The rest of them will be from, short videos for tech tips or short videos for promoting new products, whatever the case may be. So subscribe to our channel and check out all those videos. You're certainly going to find a topic that you're interested in for sure. Okay, so until we talk again next week, let's all get out there and do us some good.